this video, we'll be looking into the relations and functions module, under which we'll deal with the relations topic. So a relation R can be expressed as the subset combination of Cartesian product, that is A cross B, between a non-empty set A to a non-empty set B. So we can write it as A comma B belongs to R, says that A is related to B, and we write it as A relation B. So if there's a relation between A to an empty set, then we refer it as a binary relation. And one more thing, see, suppose if A has m elements and if B has n elements, then the total number of relations from A to B can be written as 2 power mn. So moving on to the types of relations now. Firstly, we have the reflexive relation. So a reflexive relation is a relation R that is said to be reflexive if it follows the condition A related to A, if A comma A belongs to R where A belongs to A. So let's understand this with an example. Let's take A is equal to 1, 2, 3. So A is equal to 1, 2, 3. We can write A cross A as 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 3, 1, 3, 2, 3, 3. Suppose this is the relation obtained from the given question. Okay, so from the given set. So here we can write R1 is equal to 1 comma 1, 2 comma 2 and 3 comma 3 satisfy the condition that is A comma A belongs to R. Thus this is a reflexive relation. If we take R2, suppose let's take R2, here we write 1 comma 1, 2 comma 2. So this is not a reflexive relation because here 3 comma 3 is being messed out. So all the elements of A should have a relation with itself. So that is what reflexive relation actually means. Next we have symmetric relation. Here the condition is, so A related to B, B related to A, where A comma B belongs to R and A is equal to B or A is not equal to B. So let's look into this with an example. A is equal to 1, 2, 3. Again the same subset will take, and further writing it, let's write the A cross A relation 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2, 1 comma 3, 2 comma 2, 2 comma 2 is the 2 comma 1 and 2 comma 3, 3 comma 1 and 3 comma 2. I am randomly writing the combinations, okay, just to explain this relation. So here let's take R1 is equal to 1 comma 2 and 2 comma 1 is said to be a symmetric relation because A comma B and B comma A both are related to the same set. Then we have, let's take one more example, 1 comma 2, 2 comma 2 and 3 comma 3. So is this a reflexive, is this a symmetric relation? Not symmetric. Because this does not satisfy the condition. Then we have third type, that is the transitive relation. So in transitive relation, it's pretty simple. A comma B is related to R and B comma C is related to R. Then A comma C should also belong to R, where A, B and C belong to the capital A. So any relation which contains only one ordered pair is also known as transitive relation. Okay. So let's take an example. A is equal to 1, 2, 3. So here let's write A cross A relation as 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. So here let's write relation R1. A comma B belongs to R. So 1, 2 belongs to R. Similarly, B comma C, 2, 2 belongs to 2, 3 belongs to R, and 1, 3 belongs to R. So this is a relation. Now defining this, A comma B is here B comma C is there, and here A comma C is there. So this satisfies the given condition, right? That is condition of transitivity. So thus we can say that this relation is transitive. So yes. Next we have antisymmetric. So antisymmetric topic is pretty simple. A relation R is said to be antisymmetric if A related to B and B related to A, such that A is equal to B or A comma B related to R and A is not equal to B. Here we have B comma A is not belonging to R. So let's take an example. So A is equal to 1, 2, 3 and we have R1 is equal to 1, 1 and 3, 3. So we can say that this is not reflexive, but it is antisymmetric. Similarly, we have R2 is equal to 1, 1 and 2, 2. We can say that this is antisymmetric. Then we have, let's take R3. Let's take R3 is equal to 1, 2 and 2, 1. This is symmetric but not antisymmetric because 1, 2 and 2, 1 belong to R3. Here 1 is not equal to 2. Finally, we have equivalence relation. So a relation R is said to be equivalence if it satisfies the condition of symmetricity, transitivity and reflexive. So in other words, a relation is said to be satisfying equivalence condition if it is symmetric, transitive and reflexive. So I hope you have understood how to solve this question. If you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.